Hello everyone, I Miss S.M. Jagtap from Maratha Vidya Prasarak Samajas, KBT College of Engineering, Nasik welcomes you on my today's sessions, and today I am focusing on pulse width modulation. Yes, in my previous videos I already discussed the basic fundamentals of pulse modulation. Then I discussed the pulse amplitude modulation in details, how to generate, how to reconstruct, then PPM in details. And this video will be focusing on the pulse width modulation. After listening this session, you will be able to understand the basic concept of pulse width modulation. You will be able to understand how to generate and reconstruct the pulse width modulated signal, and then we will focus on advantages, disadvantages and applications of PWM. Yes, we revise these waveforms again as the pulse modulation is of three types: pulse amplitude modulation, pulse width modulation and pulse position modulation. For the pulse modulation, we required a basic signal of x of t. It is also called as a modulating signal. It is also called as a master signal. Whereas the train of rectangular pulses are required, that is indicated by the carrier C of t. Yes, after the performing operation on the master signal and the carrier signal, we will be able to generate pulse amplitude modulation, pulse position modulation and pulse width modulation. Yes, in PAM we observe amplitude of the pulses get varies, but the width of the pulses and the position of the pulses are constant. Yes, in PPM the position of the pulses are changes, but the width and the amplitude of each pulse remains constant. Whereas in PWM, yes, today we are focusing on pulse width modulation. The width of each pulse is varied, is different, whereas the amplitude and the position of the pulses are constant. Let us focus on PWM in detail. What are the basic principles of PWM? The pulse width modulation is basically a square wave with a varying high and low time. If you observe here, this is a time period. This is a time period indicated by T on. Look at here. This is a time period indicated by T off. And T is equal to T on plus T off. This is a basic PWM signal shown in a figure. What are the different terms associated with the PWM? On time, duration of time signal. Yes, on time, the duration of the time signal is high, whereas off time, the duration of time signal is low. And what is period? It is represented as a sum of T on and T off. We can measure the duty cycle in percentage, which is equal to T on by T on plus T off. This is a basic principle of PWM. The width of the pulses are varied with respect to the time period T. What are the important parameters associated with a PWM signal? Yes, the PWM signal says on for a given time and stays off for a certain time. Sometimes it works in a on condition, sometimes it works in a off conditions. So from on and off conditions, we can measure the duty cycle of the waveform. Duty cycle is equal to T on divided by T on plus T off. The average value of the voltage depends on a duty cycle, and average value can be varied by controlling the width of on period of a pulse. Let us understand the somewhat basic generation concept of PWM. Yes, we know that PWM reduces the average power delivered by electrical signal and by converting the signal into the discrete part. Whereas in PWM technique, the signal energy is distributed through a series of pulses rather than a continuously varying analog signals. It is a type of pulse time modulation where the timing of the carrier pulse is varied according to the modulating signal due to the constant amplitude property. It is gets less affected by the noise. Figure shows the block diagram of the generation of PWM. In this, we are using a sawtooth. In this, we are using a sawtooth generator. The sawtooth generator generates a sawtooth signal of a frequency fs. Therefore, the sawtooth signal in this case is basically a sampling signal. Sawtooth generator work as a sampling signal. It is applied to the inverting terminal of comparator. The op-amp work as a comparator, whereas the modulating signal x of t is applied to the non-inverting terminal of the same comparator. The comparator output remains high as long as the instantaneous amplitude of xt is higher than that of the ramp signal. Now we will observe here this red waveform is work as a modulating signal, whereas this ramp signal is work as a carrier. The comparator output remains high as long as the instantaneous amplitude of x of t is higher than that of the ramp signal. Yes, the leading edges of the PWM waveform coincides with the falling edges of the ramp signal. Look at here. When this waveform is going to be crossed, red and blue line, it will be generate the width pulses. When it is crossing toward this side, yes, at that instant the pulse formation is not there. The width of the pulses is not predicted. When it crosses this with this crossing, definitely the width of the pulses increases and so on. Thus the leading edge of PWM signal are always generated at a fixed time constant. The occurrence of these trailing edges will be also dependent on the instantaneous amplitude. Therefore, this PWM signal is said to be trail edge modulated PWM signal. Yes, for the generation we required a sawtooth generator and we required a comparator. This represents the block diagram of demodulation or detection of PWM waveform. PWM signal is received at the input of detection circuit with the added noise. The noise is added here. The signal is applied to the pulse generator, synchronous pulse generator, which regenerates PWM signal. Whereas the second input we required is ramp generator. The regenerated pulses are synchronized to the leading edges of the regenerated PWM pulses but delayed by a fixed interval. The output of the ramp generator is a constant slope of ramp waveform for the duration of pulse. The height of the ramp is proportional to the width of PWM pulses. The constant amplitude pulses at the output of synchronous pulse generator are then added with the ramp generator in the block adder. The output of the adder is then clip off at a threshold level to generate PAM signal at the output of the clip. A low pass filter is used to recover the original modulating signal back from the PAM signal, and finally the output is generated, which is in terms of variations in width of the pulses. Yes, these are the waveform of pulse width modulation. The first waveform represents distorted PWM. When you observe this portion, the width of the pulses is affected. Some noise is added here. Whereas the regenerated PDM output is represented with a variations in width of the pulses very clearly. What is output of ramp generator? When this waveform is covered, definitely there is an increase in the voltages. For zero portion, it remains constant. As the ramp is increases up to this, whereas this portion remains stable. Yes, at this side, the output of the ramp remains increases when there is active portion of the regenerated PDM signal, and then it should be remains constant. The pulse generator output in terms of train of pulses, which is represented by this waveforms. Now, when this two signal gets added by the adder block, ramp and pulse generator, we will form the summation signal. What it indicates? Up to this portion, there is no any overlapping. Yes, due to that it is in a linear slope. After that, up to this instant, there is no any summation. So also remains constant, and then the amplitude is going to be increases. And then the amplitude is going to be increases. And finally, we got a width variations, and we got a somewhat concept of the clipper circuit with this one. Changes in a width of the pulses formation. What are the advantages, disadvantages and application? The noise level is minimum, or say that the noise is less. Noise and signal easily separate out. Synchronization between the transmitter and the receiver does not require. But to handle all this circuitry, complex circuitry, definitely the more bandwidth is required. And due to that, circuit complexity is there in PWM. What are the different application of PWM? PWM used in lamp dimmers, electric stove heater, and for maximum time for the sound production. These are the references I required to make this video. Thank you so much everyone. I hope you understand the active concept of the pulse width modulation.